day, everyone, and welcome back to the channel. Today, we're diving into a topic that's fundamental to understanding weather forecasts: atmospheric pressure. Have you ever looked at a weather map and seen all those lines and letters, like H and L, and wondered what they actually mean? Well, by the end of this video, you'll be able to read those charts like a pro. So, let's get started. First things first, what is atmospheric pressure? Imagine the air above you as a giant, invisible column stretching all the way to space. The weight of that air pressing down on the Earth's surface is what we call atmospheric pressure. It's not the same everywhere, though. It changes based on temperature and altitude, and these variations are what drive our weather. On a weather chart, you'll typically see pressure measured in units like millibars or inches of mercury. For our purposes today, we'll mostly talk in millibars. A standard sea level pressure is about 10-13 millibars. Anything above that is considered high pressure, and anything below is low pressure. Now, let's talk about those curvy lines you see all over a weather map. These are called isobars. The word iso means equal, and bar refers to pressure. So, isobars are lines connecting points of equal atmospheric pressure. Think of them like contour lines on a topographic map that show elevation. Instead of showing hills and valleys, isobars show ridges of high pressure and troughs of low pressure. Where the isobars are packed closely together, it means the pressure is changing rapidly over a short distance. This is called a strong pressure gradient, and it's a huge clue that you can expect strong winds in that area. Conversely, if the isobars are spaced far apart, the pressure gradient is weak, and the winds will be much lighter. Let's zoom in on those big letters. H and L, they stand for high and low pressure systems, and they are the main characters in our weather story. Let's start with H for high pressure. A high pressure system is an area where the atmospheric pressure is greater than its surrounding areas. Think of it as a heavy dome of air pressing down. This sinking air warms up and dries out as it descends, which prevents clouds from forming. As a result, high-pressure systems are generally associated with fair, calm, and settled weather. Think clear skies, sunny days, and light winds. On a weather map, you'll see isobars circling a central H, with pressure values increasing as you move toward the center. Air flows away from the center of a high-pressure system. Due to the Earth's rotation, this outflowing air doesn't just go straight out. It spirals outwards in a clockwise direction in the northern hemisphere and counterclockwise in the southern hemisphere. This is thanks to something called the Coriolis effect, a fascinating topic for another video. Now, for the other side of the coin, L for low pressure. A low pressure system, often called a cyclone or a depression, is an area where the atmospheric pressure is lower than its surroundings. Here, instead of sinking, the air at the surface is forced to rise. As this air rises, it cools and condenses, forming clouds and precipitation. This is why low-pressure systems are the bringers of our most active weather: clouds, rain, storms, and strong winds. They're the engines of the atmosphere. On a weather map, you'll see isobars circling a central L, with pressure values decreasing as you move toward the center. Air flows into the center of a low-pressure system to replace the rising air. And again, thanks to the Coriolis effect, this inflowing air spirals inward in a counterclockwise direction in the northern hemisphere and clockwise in the southern hemisphere. This inward spiraling, rising motion is the perfect recipe for a storm. So, we have high pressure with its sinking, diverging air bringing fair weather, and low pressure with its rising, converging air bringing stormy weather. But it's not always that simple. The interaction between these systems is where things get really interesting. The boundaries between different air masses are called fronts, and they are almost always associated with low pressure systems. You've probably heard of cold fronts and warm fronts. A cold front is where a colder, denser air mass is pushing a warmer air mass out of the way. This forces the warm air to rise rapidly, often leading to intense, short-lived thunderstorms and a sharp drop in temperature. On a map, a cold front is shown as a blue line with triangles pointing in the direction of its movement. A warm front is the opposite. It's where a warmer, lighter air mass slides up and over a colder air mass. This ascent is much more gradual, resulting in widespread, layered clouds and steady, lighter precipitation that can last for a longer time. A warm front is depicted as a red line with semicircles pointing in its direction of travel. You might also see occluded fronts, shown in purple, where a cold front has overtaken a warm front, lifting the warm air completely off the ground and often bringing complex weather. Understanding where these fronts are in relation to the low-pressure center helps you predict exactly what kind of weather to expect and when it will arrive. Let's put it all together. Imagine you see a weather chart for your area. You spot a big L to your west with a cold front trailing from it. You notice the isobars are tightly packed. What can you predict? First, the L tells you that unsettled weather is likely. The tight isobars indicate strong winds are on the way. The approaching cold front suggests that you'll probably experience a period of intense showers or storms, followed by a noticeable temperature drop and clearing skies as the front passes and higher pressure starts to build in behind it. C. You're already forecasting by simply identifying the highs, lows, isobars, and fronts. You can get a remarkably good idea of the weather for the next day or two. Let's look at another example. Suppose you see a large, sprawling H sitting right over your region. The isobars are very far apart. This is a classic setup for a beautiful weekend. The high pressure means sinking air, which suppresses cloud formation, so you can expect plenty of sunshine. The wide spacing of the isobars tells you that winds will be light and calm. This is perfect weather for a barbecue or a day at the park. However, in winter, a strong high-pressure system can sometimes lead to very cold, frosty nights, and even fog as the clear skies allow heat to escape rapidly from the ground overnight. So, the season matters too. Weather charts are a snapshot of the atmosphere at a specific moment. Meteorologists look at a series of these charts over time to see how these pressure systems are moving and evolving. This movement, or propagation, is key to forecasting. Generally, weather systems in the mid-latitudes, where most of us live, move from west to east. By tracking the speed and direction of a low-pressure system, you can predict when its associated fronts and precipitation will reach you. Modern forecasting uses complex computer models that analyze vast amounts of data, but at their core, they are still just predicting the movement and interaction of these fundamental pressure systems. So, next time you check the weather, try to find the actual weather map. Don't just look at the icon that shows a sun or a cloud. Look for the H's and LS. Trace the isobars with your finger. See where the fronts are located and which way they're moving. You'll have a much deeper understanding of why the forecast is what it is. It's incredibly empowering to be able to read the story the atmosphere is telling us. It connects you to the world around you in a whole new way. From planning a hike to just deciding whether to take an umbrella, understanding atmospheric pressure is a practical and fascinating skill. Thanks so much for watching today. I hope you now feel more confident looking at a weather chart. It's a skill that just takes a little practice. If you found this video helpful, please give it a thumbs up and consider subscribing for more content that breaks down the world of weather. Got any questions? Drop them in the comments below and I'll do my best to answer them. Stay curious and I'll see you in the next video.